program for many, many years now. So if you're interested in, again, doing technical work, getting paid to do something this summer, if you don't have an internship lined up yet, this could be an awesome opportunity. And so I'll sort of focus things on through that sort of lens as well. So let's dive in. Let's talk about Julia. And before we do that, I think it's always worth, again, taking sort of a step back, thinking about why do we need another programming language? And I think this is a really logical, good question to ask. And I think the reality is why Julia was created was really to solve what folks have dubbed sort of the two language problem, which is that you have languages like Python, which are really easy to use, high level, very friendly to users. And then you have languages like C++, which are really, really fast, less friendly, not a lot of fun to program in unless you're someone who really enjoys C++. And really there's the tension between these two different languages, in that, if you want to build something quickly and, not have a headache while you're making it, you'll use Python. But then if you want to go and take that thing into production, if it's a difficult problem that you're trying to solve, then you'll rewrite your code and actually use C++, and take that app into production, or whatever the tool is, into production. So Julia really helps solve this two language problem in that it's super fast, sort of on the order of C or C++, and it's also extremely easy to use. So syntactically very similar to a language like Python, and it's again designed to be easy to use for folks. I wanted to add one other quick thing, which is that if you have questions, thoughts, comments, feel free to just jump in. If you want to toss in the comments, that's okay. If you want to unmute and sort of say something, that works for me as well. Don't worry about sort of interrupting me or any of that sort of stuff. So feel free to jump in. But sort of what are some of the other reasons Julia is a useful programming language? Another few of the reasons why I think it's sort of one of the fastest growing, it is one of the fastest growing and actually the most loved languages as well, according to Stack Overflow. But the interoperability is a huge thing. So, if you're like me and you really didn't think about interoperability between programming languages until you heard of Julia, that's totally fine. The basic idea is that, if you want to take different programming languages and sort of combine them together, have a single file which both works with, has Python code and Julia code in a single file, that actually can happen using Julia, which is really cool. And to the point where, you could have C++, C, R, and Python all in one file if you really wanted to. I wouldn't recommend that. But what this actually enables for you as a user of Julia is that you don't need to rewrite all the stuff that you have. So if you've wrote, some really amazing Python code or the like in the past, and you don't want to have to sort of do any of that code, that's totally okay. Don't have to. You can sort of just keep the existing stuff integrated directly into your Julia file and then sort of build on top of it. The other piece too is the community and the user base for Julia is growing rapidly. So I think, again, it's a huge opportunity for students and folks to get involved now and sort of actually make contributions which have an impact, be a part of this community. And it for, at least for me personally, has opened up a ton of opportunities, and it's been awesome. And then again, we already talked about this, but the speed and reproducibility are two of the main reasons that folks from a technical perspective end up making the switch to Julia. So just a few other things. Of course, I haven't explicitly said it, but Julia is an open source project. So everything is free and not trying to sell anybody anything. A lot of folks who use MATLAB actually make the transition to Julia because they don't have to pay, and there's all these other speed and performance and usability benefits. Again, we talked about how Julia is sort of well suited for computationally intensive problems, data science, machine learning, physics, chemistry, modeling, all that sort of stuff. So lots of interesting use cases, lots of exciting use cases. And let's talk a little bit more about some of the places that Julia is actually being used for. So one of the things that I think is sort of the most interesting right now is the Klima project. So the Klima project is a collaboration from Caltech, the Naval Postgraduate University, MIT, all these other sort of renowned institutions. The idea is they're trying to build climate models that can actually simulate things to a higher degree, a higher certainty than was ever before possible. And what they're using to help them solve this problem is Julia, because of the computational efficiency and things like that, the scale of what you can use Julia for. So it's a really, really interesting problem. I know they're always sort of hiring students as well. So if you're interested in climate science, this could be a really cool opportunity to investigate a organization that's actually having an impact on the world. And again, the reason they're doing all this interesting research is because one of the really big challenges, and I just read an article about this recently, is that you know, in the course of climate change and climate science, we can propose, you know, doing something like, let's, you know, get rid of all cars on the roads, and, you know, we want to eliminate CO2 emissions from cars. Let's do that. We can actually make it happen from a policy perspective, but we don't right now have the climate models to the point where we could actually say, hey, what's the impact on the planet of us removing all that CO2? Like, would that be enough? Is it really as simple as just removing all the cars from the roads and we're going to be good to go after that? So they're really building this climate modeling software sort of with some of these ideas in mind of how can we actually look at the actions we're taking to solve climate change and understand how they're going to impact the planet, which I think is, again, super, super interesting and super cool. Another use case, which is just very, very top of mind for all of us living in the COVID age, is a company called Puma's AI, and they're really using machine learning and Julia to do precision medicine. Lots of cool things about precision medicine. Like, something that always blows my mind is, you know, two people whose body are completely different, but they have really similar symptoms, might go to the doctor and actually get the same prescription. And you and me could get the same prescription. And, you know, I'm 6'2" and weigh 210 pounds, and you could be 5'3" and weigh 125 pounds. And we get the same dosage of this medicine. And the reality is that obviously what our bodies need are completely different sort of dosages and potentially different medicine, even just because of the physiological nature of our bodies. But yet sort of medicine today is this really like template matching operation. And part of what Pumas is doing is helping with solving that problem. They also were sort of core members of helping the team at Moderna develop the COVID-19 vaccine, which is super cool and interesting. So lots of, again, really impactful work that's being done using Julia. And sort of hopefully the takeaway so far has been, you know, maybe Julia's worth trying, maybe you're still not convinced, and I'll get you later on in the presentation. But just before I push forward, any questions about stuff that I've said so far, things I can clarify? If not, then we will keep pushing forward.
So yeah, I have a question.
Yeah, sure.
So with you having some background and context of the language, in terms of longevity, do you see this language like having some level of longevity? Because I mean, I know, like, just like from my experience, it's like you see a language and then it comes out, and then, you know, there's a new language for this, for that, and then it's like I mean, I don't know. I mean, I'm trying to prioritize longevity. But yeah, what do you see in terms of like longevity with this language?
No, Brian, that's a wonderful question. So I think there's a lot of really interesting historical stuff about programming languages. Like Python, for example, has been around for something like 30 years now. And you know, it's still going strong, and it's still growing, and it's still continuing to get better. Fortran's been around for like 70 years or something ridiculous like that. So a lot of the really popular languages that we're all familiar with have sort of stood the test of time. And the cool thing is that Julia has actually been around for 10 years now. So it's, again, the sort of slow ramp up to get to the point where we are now, where there's sort of 1 million developers using Julia and all these things. But it's definitely, you know, stood the test of time thus far. It's grown to the point where year over year continues to double in users and downloads and all that sort of stuff. So everything that I've seen says that things will continue to grow. And I think we have the sort of institutional support such that the language won't just disappear in the next couple of years. Again, another sort of point of reference is a lot of the folks who are really sort of the influence / policymakers in the machine learning space are all folks who believe deeply that Julia is going to be the programming language to power the next sort of wave of machine learning and things like that. So Jeremy Howard is one of those people who created fast.ai. If you've done any machine learning work, you're probably familiar with fast.ai. Some of the other folks who lead sort of the research of machine learning at Facebook, the PyTorch people have actually said that their goal is to make PyTorch similar to Julia because we've done hopefully a good job and they really want to model things around Julia. So lots of good positive steps in the right direction, Brian. But I guess the only way we'll find out is we'll have to talk in 10 years. So send me a calendar invite.
Also, what companies actually use this type of language that you're aware of?
Yeah, good question. So I think right now, again, it's the reality is it's a lot less popular than a language like Python, but really every big company that you can think of. So I started using Julia when I was working at NASA, so used it there for 3 years. The folks, when I joined the team, were already using it. It has penetration there. There's a bunch of folks I work with at Amazon who use Julia for quantum computing stuff. There's a bunch of folks actually at Apple, supposedly, we don't know for sure, but doing sort of interesting autonomous technology who are using Julia. And I don't have sort of any insider information. I've just read a job description that talked about Julia. So that's not a leak coming from me. That's a job description. So lots of folks using it there. Again, a bunch of people at the Google research as well who I've worked with who are using it. So being used in a lot of places, just not at the same scale that a language like Python is right now.
Appreciate that.
Yeah, great question. Noah asking in the chat, how similar is Julia to MATLAB? I know you said Julia is open source. Is the community thriving? Rather, is it very active? My personal opinion is that the Julia community is thriving. I think there's a tremendous amount of new folks coming in, projects being delivered, all these sort of things. So I'm always looking at the analytics and the numbers of how things are going. And again, by every, sort of available metric I have, the community is in an incredibly good place. And how similar is Julia to MATLAB? So I actually haven't done a ton of MATLAB development myself personally. I've used it, but it was probably like 3 years ago. So I don't really remember syntactically what MATLAB looks like. I'd encourage you to go on the Julia documentation and just look through and see how similar you think it is if you're using MATLAB regularly. I don't know if I have a good point of reference to give you right now, but I do know that a lot of folks who transition to Julia are coming from the MATLAB space. It's actually really the core sort of market for the Julia community is folks coming from MATLAB. Rather, we don't want to compete against Python. We really want to sort of take people away from MATLAB because it's just not a good tool. Yeah, great question. And interested to know if you're using MATLAB regularly and what your take is as far as how similar syntactically things are. Yeah, would love to hear that. Cool. So lots of good questions so far. I appreciate that. Hopefully we see more, but just to give again sort of the context for where you might go about getting started and actually learning more about Julia. So I suggested the documentation, always a great place to start. But if you're looking for sort of a more full experience as far as learning the language goes, there's a really good course at MIT that's available to the world that I help teach. So if you go to computationalthinking.mit.edu or just Google Introduction to Computational Thinking, really awesome course, actually co-developed with a bunch of YouTubers and folks who people might be familiar, 3 Blue 1 Brown, Grant Sanderson actually helped co-develop this course as well. So the materials are super high quality. It's a great sort of way to pick up Julia, or just, again, maybe you'll do the course, realize Julia is not for you, but a lot of just really good, interesting content. So would highly suggest using that course as a starting point if you want to. Another thing to check out is the Learning tab on the Julia website. We have lots of different ways of sort of helping folks sort of learn the language, YouTube videos, Julia Academy, which is sort of all of our courses, that sort of thing. So again, lots of opportunities to learn stuff to sort of fit whatever sort of learning needs that you might have. The sort of, yeah, people talking about the linear algebra videos, another 3 blue, 1 brown videos. Yeah, incredible videos. He does a really good job. It's actually remarkable how good some of the content he puts out is. So
I had a
again,
question actually.
Yeah, go ahead.
So from your perspective, like I'm trying to understand the relationship between like machine learning and software engineering. Is there like some type of like connection relationship? Is machine learning like a step up from software engineering? Because
Yeah,
I
that's a
don't
good
know,
question.
machine learning, like when I see machine learning, I see the buzzwords like, trying to automate stuff and stuff like that.
Yeah,
That with
Jason,
data.
did you have another question, or did you want to answer Brian's question?
It kind of coincides with his question and may somewhat answer it. I myself personally don't have a ton of experience with machine learning, but I just read an article in the ACM that was recently published about reusability and how that is usually not the case when developing one machine learning application to another. So they're trying to institute new methods in which can be universally used across the field in order to try to incorporate more reusability. Is that something that Julia aims to do, or some of the stuff that you've worked on? Have you ever witnessed having to start from scratch and gosh, we really wish we can use some of these old models, but unfortunately they just won't work? Do you have anything to say on that? And to kind of answer his question, yeah, I have from that article as well, machine learning and the development of these types of applications is, according to the article, a lot more challenging compared to more straightforward end-to-end development of a different type of service that doesn't require neural networks and low-level machine learning code. So
Yeah, so I think I'll start by going back and answering Brian's question, or at least try to answer it. So Brian, the sort of core difference between what I see as machine learning and software development is software development, again, you're trying to build some sort of system using software, and you're sort of coding everything directly. All of the decision making, all of the logic is written by you as the developer of the system. In the context of doing machine learning, it's sort of an entirely different workflow. So you're getting a bunch of data, you're training a model using this data, and then you're potentially integrating that model into a software system, and that model is actually going to be the thing that makes decisions. You're not hard coding in the context of machine learning. You're not hard coding the model to see some input and then make a decision. You're letting the model learn to make those decisions itself. As far as whether or not it's more difficult, it really just depends on sort of who you are. I actually think that machine learning, the actual act of doing machine learning, is actually pretty straightforward. And the reason for that is because as a machine learning practitioner, there's not a lot of sort of code that you actually have to write. So if you ever look at like the training code for a machine learning model, or the inference code, which is when you actually go and run the model in production, it's relatively simple. It's there's not a whole lot going on there. What I will say though is that at a high level, the fields of machine learning and software engineering are bound to sort of collide together in the future. I think that in the future, 5 years from now, most folks who are doing software engineering are also going to be doing some form of machine learning, just because that's the reality of the way that the trends are going. So many more applications are using machine learning. So hopefully that answers your question, Brian, as far as the difference between the two. Jason, to go back to your question about sort of whether or not Julia helps solve this problem of sort of generalizing machine learning solutions, my take on this is that this is the fundamental problem with the way that machine learning is happening right now. Like people, talk about how machine learning is getting better, et cetera, et cetera. But the reality is that we just have more data accessible to us to solve some very specific niche problem. And if you had machine learning systems that were able to generalize and solve sort of a wider swath of problems, that would be sort of closer to the notion of artificial general intelligence. So we're nowhere near there. If you train a machine, like I've spent a year at Apple training one very specific machine learning model, which does a very specific task, it is nowhere ever going to be able to go and also solve some other task that it wasn't built to do. So everything is very domain specific. And Julia doesn't really help solve this problem because this is a more fundamental problem with the way that we build machine learning models right now. So we'll need some new technique or technology beyond the programming language itself if we want to get past this sort of domain specific nature.
So a follow-up question. So do you see the machine learning field automating software jobs?
So I mean, you see this happening to a certain degree, and the problem with automation is that people think that automation is going to take away your job, and the reality is it's not. It's going to make your job easier so you can be more effective in the way that you do your job. So I don't think that software engineering jobs are going to go away. I think they'll change. I think they'll be more effective, even like stuff like GitHub Copilot, whether folks have seen it or not, but it's basically like a machine learning based system that it's like really advanced autocomplete. So you can write like one word and it'll sort of auto populate an entire function based on all of this code that the system has seen already. So again, that's not gonna, they still need you there to write the code and make sure things are right, but your job will be a little bit easier. If Brian, and to put it a different way, if software engineering jobs could be automated away, then there'll be nothing left in life for humans to do. If you can automate software engineering, that is the final frontier. It's too nuanced, it's too complicated, and robots will be fully sentient before they can sort of do software engineering. That's at least my opinion. Maybe I'll be wrong. Yeah, no, good question. And Noah's asking, how math intensive is the day-to-day life of a machine learning engineer? This is a good question. I don't do any math, but maybe that just depends on the specific team that you're on. I'll also note that I am a applied machine learning engineer. So the focus is on taking machine learning technology, which we know works, and actually going and applying it to real problems in the real world and solving those problems using machine learning. So my focus is not on creating new machine learning technologies that don't already exist. It's really on the problem solving part. And I think if you're creating new machine learning technologies, that's where the math becomes a lot more important because you need to basically create new stuff. And again, that's not the work that I do. So applied machine learning, don't need any math, basically. Machine learning research, definitely want to have a lot of math. Wonderful questions. Let's keep pushing forward. So just a few other things as far as ways of getting involved, contributing in the Julia ecosystem. So I really wanted to highlight sort of the reality that you don't need to just dive in and start making code contributions. If folks have heard about open source before and haven't done any open source work, I think this common sort of myth is that you need to sort of dive in, like open up a PR, look at a good first issue in order to make a contribution. And I just want to provide sort of the alternative perspective, which is that there's a bunch of different ways of contributing to open source. And really, as this slide says, there is more to open source than just code. And what I really like to look at in the context of open source is this sort of arc of being an open source contributor, which starts off with something like this, where we're having a conversation about open source and different machine learning technologies and things like that. And you might take this and go to the next step of, looking into some of these technologies, opening an issue on GitHub, writing a blog post. All of these things are sort of precursors to you making this first code open source contribution. And you can also sort of go through the first 3 steps 5 or 6 or 10 times before you get to the point where you make this open source code contribution. So again, if that's something that's of interest to you and you're like, I want to do Google Summer of Code and make open source contributions, making the code contribution does not need to be that first step in the process. It can definitely be sort of part of this, the last stage of this arc, if you're sort of just getting started in the ecosystem, in the domain. So wanted to point that out in case folks are sort of relatively new to open source. The other thing that I'll suggest is, I know it's not October, it's not Hacktoberfest, but we do have a website where you can find like a bunch of issues that have been tagged for Hacktoberfest. So if you were interested in actually looking at some of the problems in the open source space and contributing, this might be somewhere good to look, just because folks have looked at these issues, they've set them up for new contributors, and it could be really helpful to start here. So this is the URL for that site is down at the bottom. What was the URL to the open source?
It was 2 slides back.
2 slides back. Oh, julialang.org/contribute. Yeah, that has sort of a whole host of different ways, again, of making contributions in open source to the Julia ecosystem. So definitely worth, again, checking out. This was the last piece, and again, this is sort of a more general pitch for open source versus talking about Julia or any of the sort of machine learning stuff we've talked about so far. But I really think that open source is sort of this fundamental way that folks are able to get experience that you normally otherwise wouldn't be able to. So I think when I pulled these quotes here, and this was from a Forbes article with some university recruiters talking about sort of what they were looking for when they hire students. And I think the reality is all of these points are sort of things that you get by contributing to open source. I think having sort of this track record of actual technical contributions can be really sort of important in the interview process. A lot of interviews now, if you interview at like Shopify or Stripe or any of these other companies, they ask you to actually provide them sort of a sample of the work that you've done before, and being able to show them sort of open source contributions could be a really cool way of sort of highlighting that you're, again, self-motivated, excited about technology, offering a fresh perspective, et cetera, et cetera. And again, just to tie things back into the Julia ecosystem, like I've been in interviews where I made some Julia contribution and have had the opportunity to share with the interviewers sort of what is Julia, why somebody would use it, et cetera, et cetera. And this really highlights the fact that like I'm bringing a different experience than every other college graduate who is, knows Python, did some C++, maybe took a Java class or two. So I think it's been super powerful and helpful for me in my own career, sort of navigating the different opportunities that have come up. So that's a super high level overview of all the exciting things. I actually wanted to again suggest folks if you're interested in learning more about Julia, I wanted to give a specific link to check out, and that is this Free Code Camp article about Julia that I wrote a few months ago. So one of the examples is at the top, the Shopify CEO talking about how he thinks Julia is the natural replacement for Python, machine learning, data science. But really this article goes through sort of all the fundamentals of the language, how to use it, sort of the core paradigms, strings, variables, for loops, if statements, all that stuff. Get your hands dirty. So I'll send this into the Zoom chat, but that is, actually it says my screen share is paused. I don't know how that happens, but yeah, so that's everything that I have. I sent the URL for that article if you're interested in learning more about the language, how to get started, all that stuff. But happy to answer questions. Yeah, this was awesome. I appreciate also all the questions that folks have already asked. Those were super great.
Quick question from my end.
Yeah.
Yeah. So the library support for Julia, how I guess like strong or robust is it, or is it becoming, I should say?
Yeah, so two parts of this. So the existing libraries in the Julia ecosystem, I think there's 7,000. So it's not like there's only a few. A lot of those, I wouldn't say a lot. There's a definite 10, 15 of those packages, which are actually sort of world-class and state-of-the-art, like the pandas replacement in Julia. Data frames.jl is world-class in speed. There's a bunch of other packages like that that are sort of the top of the line as far as the ecosystem goes. And also the amount of packages that are being developed is accelerating. So this, again, could also be a cool opportunity for folks to come in and actually, you use some Python package, you can sort of write the Julia equivalent, make that contribution to the ecosystem, and then, thousands and thousands of folks are actually going to use those packages. So it's a really cool opportunity. But yeah, definitely accelerating, definitely lots of packages already out there.
Nice.
Yeah. I have a Slack channel that just shows me every time somebody registers a new Julia package. So there's lots of them coming in, and you can it's actually public to the world. So if you are on the Julia Slack, you can look at the new packages feed is what I'm always checking out.
Nice.
Yeah, there's lots of, this is just today, like 1, 2, 3, 4, 5, 6 new packages. So lots of cool stuff being developed every day.
Really cool.
Other questions that folks have? Otherwise, you all can enjoy the extra 20 minutes of life back. Jason, you want to go ahead?
Yeah, I was actually wondering if we could ask you some questions about the other side of your life, your career at Apple, and perhaps maybe a little bit about your experience in academia.
Yeah, I would. The only thing I would say is we'll end the recording if folks don't have any Julia questions, just because I technically I don't speak on behalf of Apple. I don't want any of my personal opinions about Apple to end up on the internet.
Yeah.
So no more questions about Julia, then we can end the recording.
As far as Julia is concerned, what's the scope of like the current use case, like companies that are currently invested in Julia? I know that did you mention that Apple was currently utilizing Julia? So is this something that's specific to Apple, or are there other big names in the industry that are also on board with it? I know you mentioned one other
Amazon, Google, yeah,
Google,
lots
okay.
of. So I would say there's a ton of folks. So it's definitely not an Apple thing. I actually pretty much do a lot of the work that I do at Apple using Python, not Julia, just because that's what my team uses. So it's widely used across the ecosystem. I would say actually probably it has more adoption in academia versus Fortune 500 companies, just because of the nature of work that people do there.
So the scientific community has also kind of, because I know that the scientific community is very heavy with MATLAB right now, and from what I've heard. So
yeah, and I would say a lot of those folks are making the transition to using something like Julia. So I'd say that's probably where we have more adoption versus like large companies. And again, the reality is like Google and Apple are doing like a lot of, I mean, they are doing some science, but it's not like a ton of science versus the people in academia are really just doing science stuff. They're not just building web apps and high performance things like that.
what would you say is like the greatest argument if you just had one sentence to give somebody currently using PyTorch or MATLAB? What would you one thing that you could tell them why Julia would be a better solution?
Yeah, it's the developer efficiency. So you can solve problems faster, more effectively than you would be able to, which means you don't have to spend as much time working or doing whatever else it is that you don't want to do, because you can solve these problems faster.
Awesome, thank you.
Yeah, great question. Cool. Let's pause or end the recording then, and then I can answer Jason's question.